A candy-filled piñata is hung from a tree for Sarah's birthday. During an unsuccessful attempt to break the 4-kilogram piñata, Jeff cracks it with a 5,500 kilogram stick, moving at 4 7/10 meters per second. The stick stops and the piñata undergoes a gentle swinging motion. Determine the swing speed of the piñata immediately after being cracked by the stick. Okay, so we've just learned that momentum is conserved when we include everything in the system. So let's go ahead and look at the conservation of momentum and try to use that. So we know we're going to have a before situation and an after situation. So before, we've got this piñata hanging from the tree, and there is a stick that is being swung at the piñata. Okay? Afterwards, the stick is motionless and the piñata is moving off to the side. Okay? So, let's write down our givens. A 4-kilogram piñata. So we know the mass of the piñata is 4 kilograms. And it is hit with a 5,500 kilogram stick. So that is the mass of the stick. Moving at 4.7 meters per second. So the stick is what's moving. So we have this velocity of the stick is 4.7 meters per second. The stick stops, so after it hits, the stick is going to stop. So the velocity of the stick afterwards is going to be 0 meters per second. And the piñata undergoes a gentle swinging motion. So the speed of the piñata afterward is going to be swinging, but we don't know how fast. It says to determine the speed of the piñata, so that's what we're trying to find. Okay? So what else do I know over here? Well, I want to have something written down for the speed of the piñata to start. Well, it's just hanging there. So we're going to go with 0 meters per second. Afterwards, I need to know the mass of the piñata and the mass of the stick. Well, they don't change, okay? The mass of the piñata is still going to be 4 kilograms. Didn't break, no candy fell out of it, so it's still 4 kilograms. And the mass of the stick is still going to be 5,500 kilograms. And what we know is that the total momentum before is equal to the total momentum afterwards. So let's look at the total momentum before. I have the momentum of the piñata, so the mass of the piñata times the velocity of the piñata. And I also have the momentum of the stick, so the mass of the stick multiplied by the velocity of the stick. And that total momentum before is going to be equal to the total momentum afterwards. So the mass of the piñata after, velocity of the piñata after, plus the mass of the stick after, velocity of the stick after. So I have 4 side. I'm going to go ahead and substitute in. I've got 4 kilograms for the mass of the piñata, and the piñata is not moving to start, so the speed is 0, plus the mass of the stick, 5,500, times the velocity of the stick, 4.7 meters per second, is equal to the mass of the piñata afterwards, 4 kilograms, times the speed of the piñata afterwards. We do not know that, so we're going to write down, leave it as the variable, velocity of the piñata, plus the mass of the stick afterwards, still 5,500 of a kilogram, times the velocity of the stick afterwards. It says it's at rest, so 0. Go ahead and solve. This is going to be 0 plus, multiply those together, we get 2 and 585 thousandths is equal to 4 times the velocity of the piñata plus 0. Those zeros are going to drop out, or you can add them to both sides, however you want to get rid of them. You get 2.585 is equal to 4 times the velocity of the piñata, divide both sides by 4. And we find the velocity of the piñata is 65 hundredths meters per second, or 65 centimeters per second.